Matrix, the last time that we were together, we were talking about, well, the first week that we started, we were talking about whether a function is a function or not. We looked at whether it passes the vertical line test and the horizontal line test. And then we spent some time talking about the inverses of one-to-one functions. All right, so now we really are starting to get into the meat and bones of things per se, because these are the sorts of questions that would come up in tests and exams. They don't generally give us the inverses of one-to-one functions in exams, but we do have to consider the inverses of many-to-one functions. All right, so today we're going to be talking about the inverse of the many-to-one function quadratic functions. All right, so the first example we're going to look at is our many-to-one function, our good old graph f of x equals x squared, which is our bog standard garden variety parabola that we first learned about back in grade 10, and it's the same old, has its turning point on the y-axis. It goes through the origin, and it is a smiley face graph. All right, so if we are talking about the inverse of this particular function, all right, we are reflecting the line over, we're reflecting the graph over the line y equals x. So remember, when we talk about the word inverse, remember we said last time there is two ways that we can think about an inverse. Either we consider an inverse to be a reflection. I don't know why it keeps doing this evening, but anyway, it doesn't matter. So it's either a reflection over the line y equals x, or the other way that we can look at it is that we are interchanging x and y. Okay, so if we were going to reflect the graph f of x equals x squared over the line y equals x, right, what happens is this. We've got y equals x squared. So we're going to interchange x and y, and now we're going to have x equals y squared. Now, whether we write it that way around or we write it as y squared equals x, it doesn't matter. Normally, we have x on the left because we want to make that the subject of the formula. And now, in order to make y the subject of the formula, we would need to take the square root on both sides. So y would be equal to plus or minus the square root of x. Okay, so when we take plus or minus, what we are saying is that the sign of y changes. So either we are considering, all right, for example, where y is positive, or we are looking at where y is negative. Okay, so where is y positive? Where is x? Sorry, where's y positive, where's y negative? So just to go back to our Cartesian plane again, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, x is going to be positive. Let's just put that on there over there. So x is positive in quadrants 1 and 4. So it's this region of the graph over here where x is positive. It's this region over here where x is negative. Okay, y is positive above the x-axis. This is where y is positive, and over here, this is where y is negative. And this is going to be important for us because they do also expect us to be able to write the domain and the range of our functions as well. Okay, all right, so let's go down here and have a look at what it would look like once we have done our, or applied our inverse. So we've got y squared equals x. As I've just shown you over here, making y the subject of the formula, it would be plus minus the square root of x. So here is our original function matrix in green. Whoopsie, I'm not, not drawing this very well. There you go. Here is our reflection line, y equals x, and here is our inverse. Okay. And there is its equation over there. Okay, now, if we consider what we were talking about last week, we were saying that the inverse is not a function, right? So if we move this, keep doing that this evening, it's very irritating. Ach, yes, like it, man. Let's grab this. Okay, so if we hold the purple line over here, can you see it cuts the yellow graph in two places? So in other words, the yellow graph is failing the vertical line test. So the inverse of our graph y equals x squared, our inverse is just a relation. It is not a function. Right, so what we're going to talk about this evening is how we are going to make that yellow graph a function. All right. Okay, so there are two ways in which this can happen. Just consider both of these ways. All right, so don't worry about all the writing here on the page. We're not going to go through all of that. I just wanted to keep it there so that if you did want to come back and read this again, or if anybody else was watching these videos, that they would be able to do this, right? So in order to ensure that our inverse is also a function, we do something which is known as restricting the domain. So we restrict the domain of the original function. Okay, so what we've got here is our original parabola. Okay, when I have restricted the domain to where x is positive, I've literally chopped off one of the arms of the parabola. So I'm only looking at the arm that's now in the first quadrant, and I'm pretending that the arm, well, not pretending that it doesn't exist, but I'm not considering the fact that it exists. So in other words, I have restricted the domain only to where x, beg your pardon, only to where x is positive. What this means now is that that yellow arm that we've got highlighted on the page, that is no longer a many-to-one function. It is now a one-to-one function. Okay, and that is the arm that I'm going to reflect over the line y equals x in order to create the inverse function. All right, so here is my original arm where my domain was restricted. Here is my line y equals x. It's the line over which I am reflecting. And what would end up happening is that I would only see this particular arm of the parabola over there. Okay, so in other words, where does this come from? If we're having a look at the originals, okay, it's these over here. So I'm going to get rid of all of that. And I'm just going to show you again. All right. So now this is what we're looking at over here. Only looking at this arm in the first quadrant. We've restricted the domain to where x is positive. And when we reflect that over the line y equals x, we end up seeing that. That's what we're looking at, okay, in this diagram below. All right, is everybody happy with that? Is that making sense? Why do we restrict the domain? So how will we restrict the domain? Because if we don't restrict the domain, the inverse is not a function, it's just a relation. Okay, so that's why we have to restrict the domain. So we're going to restrict the domain of the original function so that its inverse can also be a function. That's the idea. All right, so here I could write this as f of x equals x squared. That's my original function. Now that I have restricted the domain, I could write the green one. I can just maybe write that in green. I can write that as f to the minus 1 x equals positive root x. Okay, this is where x is positive and where y is equal to 0 or y is positive. Okay, thumbs up, thumbs down, how are we feeling? Is this making sense to everybody?
Okay, looks like it's
Okay.
about, yeah, half.
All right, so I went a little bit fast. Oh, shame. Sorry, guys. All right. Okay, so Schwetzel, Where have I lost? Where have I lost? You've got a question? You're welcome to unmute and ask, Chwetso. Don't know if that was a mistake then. Chwetso, if you do want to ask a question, you're more than welcome to unmute. I'm just going to deal with everybody's shame and their thumbs downs because there are a few people that are confused. Okay, so guys, where have I lost you exactly? What is it that you don't understand? Can you perhaps give me... Okay, that's fine, Chwetso. Can you just give me an idea of what it is that you're struggling to understand here with what I'm discussing? The restrictions. Okay. That's fine. We can go through that again. All right. So restricting to where x is positive and where x is negative. Okay. So Lutando's given me an idea. Okay. Shane, that's fine. Is there anything else that's confusing you guys? Chloe. All right. Same. So the restrictions. Okay. A little bit too fast. So how will restrictions as well? Okay. So that gives me a place to start. Okay. So what I'm going to do is I'm going to scoot all the way over here to the right-hand side. Okay. Okay. All right. So let's go back here. And we'll talk about these restrictions again. Okay, so let's draw ourselves a Cartesian plane. There we go. All right, so we've got a Cartesian plane on the board. Right. When we sketch a normal, the part of the quadrants, okay. So we know that this quadrant over here is called quadrant number 1. This quadrant over here is always quadrant number 2. This quadrant over here is always quadrant number 3. And this quadrant over here is always called quadrant number 4. Okay. So when we are working in quadrant number 1, both our x coordinates and our y coordinates are going to be positive. When we are in quadrant 2, our x coordinates become negative and our y coordinates remain positive. When we are in quadrant 3, our x's are negative and our y's are negative. And when we are in quadrant 4, our x coordinates are positive and our y coordinates are negative. So in other words, if we consider where is x positive? X is positive in quadrants 1 and quadrant 4. So anything to the right of the y-axis is the region of the Cartesian plane where x is positive. Okay, so quadrant 1 and quadrant 4. If we consider where x is negative, that would be to the left of the y-axis. So in other words, in quadrants 2 and 3. Okay, as far as y is concerned, y is positive above the x-axis. Right, y is negative. Let's use a different color here. Let's go with blue, maybe a softer blue. Y is negative below the x-axis. Okay, so we have our original function. Let's draw it in purple. There's our original parabola. There's the one arm, and there's its other arm. Okay, this is the graph f of x equals x squared. So when I restrict the domain, this is what happens. Okay, if I only look where x is positive and where, okay, so here's where x is positive and where y is positive. then what that means is that I am essentially getting rid of that arm. That's what I'm doing when I'm restricting the domain. I've essentially rubbed that arm out, right? Similarly, I'm going to put it back now, okay? Badly. If I now want to look at that region of the Cartesian plane where x is negative, but y is still positive, then what I'm doing is I'm rubbing out this arm of the parabola. Okay, so that's what the restriction means. Now, the reason why I have to do the restriction is because when I do my inverse of this function is not a function, it is a relation. All right, so if I invert it and I sketch it, it's going to end up looking like this. All right, so the green graph is the inverse of the purple one. The reason that it is not a function is because it is failing the vertical line test. So if I now, let's just get a vertical line and put it on here. There is a vertical line. Okay, I'm going to take this vertical line and I'm going to move it. Can you see how the green graph is failing the vertical line test? Okay, because it's cutting the green graph in two places. If I do that with a purple one, it's not failing the vertical line test. Okay, so that means that it is a function. But the green graph, the inverse of the purple one, is not a function. So I want it to be a function. So if I want it to be a function, I have to restrict the domain of my original function. So what happens is this. When I rub out this arm over here, my purple graph is still a function. My purple arm is still a function. It's not a many-to-one function. It's a one-to-one function. And if I reflect that over the line y equals x, then essentially what I end up with is this. Okay. If I put those lines back, okay, and I put the green one back, that's not the only way that I can restrict the domain. Because what I can also do is I can get rid of, let's just make this a little bit smaller so that we don't end up, or I don't end up rubbing everything off. I can also restrict the domain Okay, so now what I'm going to end up with is only that left arm. And if I now do the inverse or I flex it over the line y equals x, then I end up with that arm over there. Okay, so the purple one is the original function. The green one is its inverse. Is that making a little bit more sense when it comes to the restrictions? Okay, I see there's some hands. Okay, Chwetzel, go for it. Ask your question. Chwetzel, you're welcome to ask your question if you want to unmute. Okay, Chwetzel, maybe we'll come back to you. Ola, you're welcome to unmute and ask.
Afternoon, ma'am.
Afternoon, Ola. How are you?
I'm good and you.
I'm fine, thank you. What's your question?
Ma'am, in a test or a question, right? Will they specify like in which quadrant we should restrict the graphs or should we already know?
Absolutely. Absolutely, they will. Absolutely, they will. That's the whole
Oh,
idea. So in a test or an exam, they probably won't expect you to do both, all right? But in order for me to be able to do the test and the exam questions with you guys, I've got to do the theory with you. So I've got to show you both ways of restricting because they could give you either one of the two. So what I'm hoping to do this lesson is to show you the sort of question that they would give you on this. But yes, they will tell you where to restrict. Okay, so whether
okay.
the domain should be restricted to where x is positive or to where x is negative. Yes, absolutely.
Okay, thank you, ma'am.
Cool, thanks for your question. All right, and then Katlego, you also had a question. You're welcome to
Hi, ma'am.
unmute and ask. Hi.
Ma'am, I wanted to know, ma'am, specifically about these two graphs, the inverses. You see, ma'am. So, ma'am, the green graph is the y is negative, yeah, which means it's
Correct.
smaller than 0. So, ma'am, when you read it on a question paper, ma'am, how are you going to see it? Because, ma'am, this is very confusing for me, the domain and the range. So, ma'am,
It
can
is
you please just...
It is confusing, absolutely. So when we look at this green line, the one that's on the graph at the moment, it is in the fourth quadrant. That is where x is greater than or equal to 0, and it is where y is smaller than or equal to 0. Okay, so x is still positive, but y is negative. Okay, so when they ask you for the domain and the range, they're asking you for your set of inputs and your set of outputs. That's the whole idea. All right. So if I now go back to what I was doing originally, if I put that purple arm back like that, okay, and let me pretend that I'm going to get rid of the green one completely, and we'll talk about that just now. Okay. If I asked you for the domain and the range of this original function, okay, let's just get rid of those. Let's just make that into a different color. If I asked you for the domain and the range of this particular function, all right, your range, let's talk about your domain first, okay? So this arm of the parabola here keeps getting wider and wider to the left. This arm of the parabola over here keeps getting wider and wider to the right. So in essence, what is happening is that it is going to the left to negative infinity, and it's also going to the right to positive infinity. So as far as your domain is concerned, we would say that x is an element of the real numbers. Okay, the other way of writing that is that x is an element, oh, sorry, not block bracket, it must be a round bracket, from negative infinity to positive infinity. Okay, so that's the domain on your original function. Your range on your original function is a little bit different. Here we're looking at what's happening in terms of y. So in other words, we come all the way down from positive infinity, the graph gets to 0, it turns around and it starts going up to positive infinity again. All right. So y doesn't go from positive infinity to negative infinity like x does. All right. The smallest number that y can be is 0. And then it goes all the way up to positive infinity again. That is your range. Okay, so your x's is what's happening left and right. Okay, what the graph is doing as it moves left and right. Your range is what's happening up and down. Okay, so in terms of the biggest number it could be and the smallest number it could be vertically. Your domain is your smallest number it can be left to right. Okay, does that make a little bit more sense about domain and range?
Yes, ma'am. Thank you very
Okay.
much, ma'am.
All right, Katlego, no problem. Okay, Danelle, I see you've also got a question. Go for it.
Hi, ma'am. Can you hear me?
Yes, I can hear you just fine. Go for it.
So, ma'am, just for some clarification, when we are given a restriction, one line will always be erased out.
Yes, yes. So one arm of the parabola has to go away in order for the inverse to be a function. All right, so either we're going to erase the arm on the left or we're going to erase the arm on the right. Okay, and then when we do our we do our inverse, then our inverse is also going to be a function. Okay, you happy with that?
So, ma'am, will both the normal graph and the inverse graph have different restriction, or they have the same restriction?
Yes. So what they will have is that the restriction would be the same with both. All right. But how you would write the domain and the range, that would change around, because what was your domain would now be your range, and what was your range would now be your domain. Because remember, x and y have swapped with one another. Okay. I haven't got to discussing that just yet, but we would, yeah, you would have to do that if they asked you for it. Okay. Sahawu, potentially they could, no problem, Danelle, no problem. Sahawu, potentially they could ask you, but I mean, when you say you would have to draw the restriction, it's drawing either arm of the parabola. Okay, so the restriction means which arm of the parabola you're drawing. Okay. Lutando, okay, does that make more
Thank
sense
you,
as well,
ma'am.
Danelle? No
Thank you,
problem.
ma'am.
Pleasure. Lutando, you are asking, ma'am, I never understood how or where we put the square bracket. Okay. Okay, Ria, you're just going to carry on asking a question. That's fine. I'll come back to you. Lutando, square brackets are where numbers are included. Round brackets are where numbers are not included. Okay, so now when we say it can be included, right, this is what we mean. All right, let me just move over to the right-hand side. I don't know if I can move any more to the right-hand side. I think I've used up what I can. Let's draw a different graph. Okay, so there we go. I'm going to draw another parabola, but this parabola is going to be a sad face parabola. Okay, so this is the sort of thing that we would have seen in grade 10. Okay, over here, that is the point. So let's say that this is the graph f of x equals minus x squared plus 4. So it's a sad face parabola and it's been shifted up 4 units. So the coordinates at this point over here would be 0 and 4. Coordinates of this point over here would be -2 and 0, and this would be +2 and 0. Okay. The graph is still, irrespective of the shape, irrespective of whether it is smiley face or sad face, the graph keeps growing to the left and to the right. Those arms continue to get wider and wider and wider. So here I would still say that x is an element of the real numbers, or I would say that it goes from negative infinity to positive infinity. So I'm using the round brackets because I cannot include infinity. Infinity is not a number, so it cannot be included. Right, because the idea is that it goes on forever and ever and ever. That's why I'm using a round bracket. Okay. When I talk about the range, however, this particular graph has a maximum at 4. So it cannot produce, x cannot produce any y that is bigger than 4. 4 is the biggest y I can get. So in other words, my range in this particular situation, I would do one of two things. I would either say y is smaller than or equal to 4, because 4 is the biggest number. 4 is included. 4 is one of the outputs. Okay, it's the biggest output. That's why I can include it. So here the graph comes up from negative infinity. It gets to 4. It can't be any bigger than 4, and it starts to get smaller again. So another way that I can write that is y is an element of. Now the smallest number has to go on the left. So that would be negative infinity. The biggest number has to go on the right. That would be 4. I can't include infinity. I am including 4, and that's why I would use a block bracket. So a square bracket goes with smaller than or equal to or greater than or equal to. A round bracket goes with smaller than or greater than. Okay, that's the idea. I hope that makes sense. Whose question was I answering? Lutando's question. Yes, Chuetso, that's exactly right. 100%, that's exactly what I was saying. Okay, good. Ria, I'm so glad. Naledi. Yes, Naledi. Okay, so the only time that we need to worry about the restricting of the domain is with your quadratic function. And that is because the inverse of your quadratic function is not a function. Okay, it is a one-to-many relation. It is not a function anymore. So that's why we have to worry about restricting the domain. Okay, I hope that makes a bit more sense. What I want to do is just go back here. I'm just wondering if it might be easier for you. Oh no, I don't know if that question's going to help you guys. Okay, let's go back and go and have a look at how we would sketch all of these, right? But hang on, I don't think I got as far as that. Oh no, I did manage to explain that to you. All right, so let's go down here and let's go and have a look at these questions and let's see if we work through this, if this is going to help things to fall into place. Okay, so Pinga, very good question, right? When you are talking about a function, Pinga, okay, a function can be a many to one function. Okay, for example, your quadratic function or your parabola, or your cubic function, which is a function you're going to study later this year, right? Then we can talk about something that is a one-to-many relation. Okay, do you see? I do not use the word function. And this is your inverse of your quadratic function. That is a one-to-many relation. So it all goes back to how many elements of the domain are associated with the elements of the range. Okay, so if I just go back up to my picture, this one is the best one for us to look at. Okay, so let's highlight this guy in yellow. The one highlighted in yellow, all right, is a many to one function. The one that I'm highlighting in green is a one-to-many relation. Okay, so where it comes from is this. Let's draw our vertical line. Let's draw it in pink, and then it'll stand out. There we go. There it is in pink. Okay, so in our first lesson, we were talking about, is it a function, is it a function, is it a function, right? And remember how I had taken a line and I had gone from left to right over a function. So ignore the green one for now and just look at the yellow one, okay? Can you see when I move the pink line over the yellow one, it only cuts the yellow graph in one place at a time, okay? So that is what we refer to as a many to one function. The reason why we call it a many to one function, right, is because it is okay. Remember the horizontal line tests whether it's a one to function or a many to one function. So the reason why we call it a many to one function is because we have got one y value. Where that pink line is, there is one y value. So for example, the coordinates at this point over here, let's pretend that that is 3 and 5. If I reflect that point over here, it would be -3 and +5. Okay, so two different x's can share the same y. That is allowed. Okay, so in other words, in my domain, if I have got the number -3 and I have a coordinate of y is 5, that's allowed, right? But in this particular situation over here, the one in green, let's just draw this. The reason why it is not a function, okay, it fails the vertical line test for starters. And let's pretend I have reflected this over here. Okay, so if that is the point 5 and 3, over here, this would be 5 and -3, right? So I cannot have the same x sharing or having two different y's. Then it's not a function anymore. Right, it's no longer a function. It is now referred to as a one-to-many relationship. So the one part refers to the x. The many part refers to the y. Okay, so here we have a many to one. Okay, remember the many refers to the x. The one refers to the y. Okay, so a many to one is a function. A one to many is going to be a relation. I hope that makes a bit more sense now. I'm just sort of reading the answers that you guys, yes, there we go. Correct. Yes, 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 yes. So Ria, once you have established that your graph is a function, the horizontal line test then establishes whether it is a many-to-one function or whether it is a one-to-one function. Okay, so in the case of a straight line or a hyperbola or an exponential function, these are all one-to-one functions. All right, because what we would find is that a horizontal line would only cut the graph at one place, all right, at a time. Okay, I hope that makes sense to you. Danelle, do you want to ask again? You're more than welcome.
So, ma'am, are you saying that there can't be a repetition of x values?
Yes, so what I'm saying, yes, that's what I'm saying. That's what I'm saying. Okay. You can't have the same x with two different y's, but you can have the same y with two different x's.
Okay, thank you, ma'am.
Okay, this is conceptually very, very difficult for us to understand in the beginning. And often what happens is that we don't understand functions in grade 10, and then we go into grade 11 and we still don't really understand functions. And then when they start doing inverse functions with us in matric, conceptually this becomes quite difficult for us to understand. So anyway, I hope that I'm helping you guys to get to grips with all of that. All right. Okay, are there any more questions before I continue? Katlego, go for it.
Ma'am,
Mm,
I just had an idea, so I don't know if it is right, ma'am. I just want you to correct me if I don't understand it in the right way.
sure.
So, ma'am, what you're trying to say is that for like a graph to be a function, well, I'm going to take it as a relationship, ne? Y is a person and X is two people. So two people can have a reason why they broke up with someone, but someone can't have two reasons. Can't break up with two X's for like one reason.
Yeah.
Does that make sense?
That does make sense. That does make sense. You're basically saying exactly the same thing that Danelle was saying, but just in a different way. Absolutely.
Okay,
Yeah.
ma'am, as long as I understand it, thank you.
Yeah. No, you do. You do. Well done. Perfect. Okay, very nice. All right. So what's really nice to see is that the things that you're starting to put onto the chat now, I can see you're starting to understand these concepts, which is really nice. Any more questions before we move on? Are we all good? Okay, Mbalenhle, go for it.
Ma'am, I wanted to ask if like how then do we like restrict the graphs?
Okay, so I think what I need to show you is a question based on something like this so that you can see what it is that I'm talking about. Let me just see what question I had for you down here. Let's just see. That one's not gonna help. No, that one's not gonna help either. again, that would be just a little bit too advanced for where we are right now. That's not going to help. This is the right idea, but that's not. Okay, so in other words, let's just go back to where we were. What they might do in a situation like this is give you a question. Let me just see if I've got something here that I can just. Don't think. Okay, hang on. Let's just see what they've got here. So I think the question that I've. Can't really find anything in the sort of online tools that I've got at the moment that I think would be suitable. But what they would do is that they would not give you the both graphs and then ask you to restrict it in two different ways. What they would probably do is they would restrict the domain for you and then ask you to draw the graphs and to answer questions on it. Okay, so this is like a sort of classwork activity that you would do in the beginning in order to understand the difference between the two. All right, so either way you are restricting it to where x is positive or where you are restricting to where x is negative. So what I want you to understand is that the restricting of the function, all right, basically means which arm of the parabola are you drawing? So when you restrict the function to where x is positive, you are only drawing the part of the parabola that lies in the first quadrant. Okay, like the picture on screen. If they ask you to restrict the domain to where x is negative, then you are drawing this part of the parabola. So in other words, the left arm of the parabola, in other words, the one that would have been in the second quadrant over there. Right, that's what it means to restrict the domain to where it is negative. Okay, so they would give you either one of these two. They're not going to give you both at the same time. Does that make you guys feel a little bit better? Yes, it does, Tegofatso, because if you don't understand the concept, how are you going to answer any questions on it? Okay, you've got to understand the concepts before you can go and answer the questions, because the questions are going to ask you to apply the concept. So you can't apply a lack of understanding or a lack of knowledge to something, can you? I mean, I don't know about you, but I don't know anything about rugby. So if you put a rugby ball in my hand and said to me, go onto a field and go and play rugby, I don't know how to play rugby. I don't know the rules. I don't know what I'm supposed to be doing. I've got nothing to apply. So I need all this groundwork if I want to go and answer questions or do the work. Okay, that's the idea. Kamachelo, what's your question?
Hi, ma'am.
Hi.
Hi. So I wrote a couple of notes down that I'd like to run by you just to make sure that I wrote everything okay. So I wrote that down that the domain is a set of the x values where the function is defined.
Yeah.
Then the rest is a set of y values of the function.
Yes. Yeah. So the range is the set of output values. Yes.
Oh, okay. And then the part that I didn't quite understand, it's the part of the why we restrict the domain. I just can't quite get that part, but everything else I did get.
Okay, so if you don't restrict the domain, then the inverse of your parabola is not going to be a function. That's why you're doing it. Okay, so in other words, if we go back to this diagram over here, all right, the yellow graph is a function. The green graph is not a function. It fails the vertical line test. So that's why you have to restrict the domain. So in other words, chop off one of the arms of the original parabola so that the inverse can also be a function.
Oh, okay, ma'am. Thank
Okay,
you.
that's the idea. Okay, all
Thank
right,
you.
no problem. Yanela, if a given parabola stops at -2, yes. So then, Yanela, what's possible is that you can restrict it like that if you wanted to, absolutely. So in other words, let's say I drew a parabola exactly like the one that I've got here on the board, okay? And my parabola does that. And it stops here and it stops there. So let's pretend that at this point over here, this coordinate is -2 and 1. And let's pretend over here that that coordinate is 2 and 1. So I've restricted it in terms of x, but I've also restricted it in terms of y. So what I would say here, as far as x is concerned, x is an element from and including -2 to 2, so written with block brackets. Or if I wanted to, I could write that as x is greater than or equal to -2, but smaller than or equal to 2. That's restricting the domain. By restricting the range, I'm also saying I'm not getting any bigger than 1. My smallest y value is 0. So as far as my range is concerned, y is an element from the smallest number, so that would be 0, up to 1. Or if I want to, I can write it as follows. Y is greater than or equal to 0, but smaller than or equal to 1. So there's an example of me restricting both the domain and the range. Okay, Yanela, I hope that makes sense. Yes, what you've said there is correct. And then around the infinity, it would be around bracket. Zechofatso, does the formula of a... No, it doesn't. All right, so it would still be the graph of f of x squared f of x equals x squared. Okay, what I would just say there is that for where x goes from -2 to 2, or from where y goes from 0 to 1, I would just have to write that. Okay. So when you are writing the domain and the range of the original function, so let's go back to the yellow here, all right? If I was asked to write the domain of this original function, if I want to write it using, I can't write it using set builder notation, but if I want to write it as x is an element from -infinity to +infinity, I can do that. All right. Normally, Ria, what we don't write this in the form of an inequality. So in other words, instead of me writing it in this way over here, when I have restricted the domain, I can write it like that. But when I haven't restricted the domain, we don't usually put your infinity symbols in with set builder notation. So we don't normally write it like that. I don't know why. We just don't usually do it that way. We'd normally write it like this with the brackets. What we would actually say instead of using set builder notation is we would say x is an element of the real numbers. Okay, so that would replace x is greater than infinity, but greater than -infinity, but smaller than infinity. Okay. Yes, so what you are doing when you're restricting the graph, okay, we weren't restricting its range. That wasn't the problem. We were restricting its domain. Okay, so as far as its range was concerned, the graph was still going from 0 up to +infinity. Ah, good question. So what would be the domain of the inverse? Perfect. Okay, so now we are considering, let's only consider that over there, okay? And this bit over here, right? So there is the domain of my original function. Here is my range of my original function. Okay, so the range of my original function is going to be y is an element from 0 to positive infinity. Now let's look at the inverse. I'm going to rub this off. Okay, so as far as x is concerned, can you see x does not get any smaller than 0 and it keeps going to infinity? So here I would say that x is an element from 0 to positive infinity. This is now for the inverse. As far as y is concerned, okay, my graph, so left to right, it doesn't get any smaller than 0, but it keeps going on to positive infinity. As far as y is concerned, here I would say y is an element of the real numbers. So in other words, when you are doing the domain and the range of the inverse, because you have had an interchanging of x and y, what was x is now y, what was y is now x. So you can see that what was your domain is now your range, and what was your range is now your domain. That's also, I think, conceptually quite difficult to understand. All right, but hopefully that answers your question, Londeka. Okay, so the range of the log function, okay, well, it depends which log function you're talking about. Okay, so there's 4 log functions. All right, so, but we're not talking about log functions yet. We are going to be talking about them on Thursday, though. So, Messina, we can do that then. Letu, for that quick example on the left, if the graph doesn't touch the x-axis, what would the range be? When you say the graph doesn't, are you talking about the green arm not touching the x-axis? The red example. Sorry, okay, just hang on later. I'm just going back to read what you've said here. For that quick example on the left. Oh, okay, all right, that same one in the red there. If the graph doesn't touch the x-axis, what would the range be? Okay, Letu, fine, not a problem. So in other words, if you had a graph that did that, and let's say over here that was 1, all right, then your range, y would be an element from, and it would be positive 1 to infinity, like that. Okay, rather than 0. So that's that question. Okay, Letu, hopefully we've sorted that out. Mihlali, if the yellow graph didn't touch the x-axis, what would happen to the graph? Okay, Mihlali, you don't need to worry about graphs like that as far as inverses are concerned. So we don't worry about inverses and shifts. All right, so as far as you are concerned, your original function is always going to touch the x-axis. So don't stress about it being shifted up. Okay, so Ria, if you are given endpoints, so let's say they give you something, there's your x and your y axes, Ria, and they give you a line that does this. And let's pretend over here that the coordinates are -5 and -2, and let's pretend over here that the coordinates are 3 and 4. Right, so if I now wanted to write my domain, I would say x is an element from -5 to 3. My range, y, is an element from -2 to 4. Okay. Hopefully that answers your question, Ria, with the linear function. Letu, we've taken care of. Do we take? Okay, so please just do the poll in the meantime. You could potentially Kamogelo. Yeah, you could be. Sometimes in exams they can ask you to explain something. Not a very common question in maths, but they can ask you to explain something and provide a reason. Absolutely. I have seen that before. Yes, so that's exactly it. Okay, Ria. All right, so your start point, so your smallest x value to your biggest x value, your smallest y value to your biggest y value. Okay, that would be your range if you were restricting it. Okay, and then similarly if you were restricting your domain. Yeah, so please do answer the poll and then you are welcome to go. It's a pleasure, Janelle. I hope you found it useful and enjoyable. Pleasure, Tsagofatso. Pleasure, Ria. Pleasure, Janelle. Bye, Trish. Bye, Letu. Bye, Shane. Pleasure, Orotile. Annika, if you want to ask a question, you're very welcome.
No, I'm fine, ma'am. I'm fine.
Oh, okay. Sorry, I just saw your hand go up. That's fine. Okay. Kamogelo, do you want to ask a question?
Ma'am, so so an inverse of a function is that the value of the x-intercept change with the the value of y.
So it's not, yes, so you're right. Yes, your x and y intercepts do interchange with one another. What was your x-intercept becomes your y-intercept, vice versa. That is true. When we are doing an inverse, what we are doing is we are switching x with y. So we're switching input and output. What was originally going in is what's coming out, and what was originally coming out is what's going in. All right, so it's like making the x-axis the y-axis and the y-axis the x-axis. That's what you're doing.
So do we also does that also happen when we do the domain and the range? Does the domain become the range?
Correct. Yes, absolutely. So when you're talking about a function and its inverse, what was the domain of the original function is the range of the inverse. And what was the range of the original function is the domain of the inverse. Okay, so literally everything about x and y has swapped.
All right, thank you, ma'am.
Okay, it's a pleasure, no problem. No problem, Pinga. Pleasure, Offense. Pleasure, Asanele. Have a good evening.
Have a good evening, everyone. You guys did well.
Have a good evening. Sure. And then somebody's just asking me to go to the top. Oh, Mihlali. I think that's what it was. Okay. And then Musina, you've got a question?
Hi, ma'am.
Hi there. How are you?
I'm fine, thanks. And how are you? My
I'm
name's
fine, thank you. Your name's Kagiso. Okay,
Yeah.
sorry, Kagiso. We'll try to remember that next time, and then we'll change your name. Just remind us too, okay?
Ma'am. I'd just like to ask, like the recordings, ma'am. Where do we get them? And is it possible for me to access the recordings from last year?
Absolutely. Yes. The answer to that is yes. So if you go onto the Watobe website, so it's www.watobe.com. You will see when you call up the page, there will be something there where they talk about the grade 12 classes. So if you click on that, you will find your way into the recordings for 2022, as well as what's happened so far in 2023. So as a student, you have got access to last year's recordings as well. So if you want to go back and watch previous lessons or lessons on different topics, everything will be there for you. They're all named, and you would just be able to find the topic and then find the particular lesson. Okay, so last year we did a lot of these courses in sort of a huge amount of detail. So yes, all of that's there for you.
Another question. Sorry, ma'am. I heard there
Go
were
for it.
quizzes. This is like my first class. I heard there's quizzes. How do we also go to the website to go check out those things, or?
No. So what would happen as far as the quizzes is concerned is that a link to the quiz will be posted in the chat. So I think there is also a link on the website as well. But generally the idea or the understanding is that you would do the quiz on the evening, on the Thursday evening. So the quiz would be on the Tuesday's work and on the Thursday's work specifically for that particular week. And then Yolanda will post that link into the chat. You would then click on it and it would open it up, and then you could go ahead and go and answer the questions.
Thank you, ma'am.
Just in addition, it's also on every single Thursday of all the lessons that are on the website or on Watobe's website, you should actually find the links to do quizzes that are long past due. So you should be able to practice those. It's just that we won't see the marks for it, but you'll be able to see your percentage on how you did on that topic. So you are allowed to do as many quizzes as you would like and as many times as you would like for practice. It's always available for you.
Thank you, ma'am. Thank you.
Awesome, Yolanda. Thank you. Yes, you too. Have a wonderful evening.